Welcome back. So, in the previous class, we decided that we needed 3 scripts, or at least 3 base scripts, an interface, a request manager, and a request. So, what I like to do with my programming when I'm creating a library is to imagine how the end programmer is going to use it. This is going to make much more sense once we're here. Okay, let's start with the most empty script we can. Let's create a nothing function just to give an idea of how we want the code to look. Request manager dot start new request. My question, my answers on request finished. My question is, how do you do? My answer is obviously going to be, you don't have to copy that, by the way, this is not a class, this is not a tutorial, this is more like a class of logic. So, how do you do? Good, bad. An array of answers, we don't know how much. And finally, on request finished is going to be a callback. Public void on request finished. So what I suggest is that start new request is going to return an object of type request, my current request. That way, if I want to update regularly, add more callbacks, etc., etc. Actually, yeah, we can just remove that. Oops. My current request dot on request finished on request finished. So now we have the class request that kind of created its own need. We have a second class request. So a request, it's let's make it public but read only. As question, the question asked to the audience. We are going to have an array of possible answers, and we said that we wanted an action. Public. Okay, so this might never get called if there is nothing that stops the request, a timer, for example. Let's make a constructor that takes the question, the answer, and no, we've decided that this was not read-only. Base constructor for a request. Okay, so I don't want to go through the trouble to have a complex object creation, so we are going to make a static class actually. Okay, so public start new request. Now that we have the base idea of how the request manager is going to work, we do it. This is public, anything or anyone can ask for a new request. Returns an ongoing request if it could be created, null if it couldn't. It doesn't throw anything. And therefore the request manager has to be the one deciding. The request manager cannot decide if it's capable or not to create a request. So the interface is the one that knows if it can or not. iRequest handler. An iRequest handler is going to be an interface, something that's capable of handling requests. Again, it can be anything. Everything that we are doing right now isn't related to the game directly and isn't directed to the Twitch API directly. The reason for this is because I want to make something generic. Don't do this all the time. If you can do something in 10 seconds or in 2 hours, pick the 10 seconds. What an interface can do? It can start request. Public request, start request. Yeah, the request manager is going to be the one creating the request, and the request handler is going to be the one handling it. That makes sense, right? Okay, starts a new request. I was gonna say we need to call canStartRequest first, but the thing is, since startRequest isn't returning anything anymore, it can just return something. Returns true if the request could be started, false otherwise. What we have as answers is an array of strings. Each string is going to have a number of votes, basically. Some people voted answer 1, some people voted answer 2, etc, etc. So, we are going to hold an array of ints. So, let's get back to imagining a whole other piece of code, and I want to start a request. I ask the request manager to start a new request. Hello, how are you? New array of strings. Bad or good. This returns to me a request. If request is not null, then we have our request. Request.on request finished. On finished. We want to do something on vote count changed. Yeah, okay. The request is going to be the one handling the voting and all of this. On vote count changed. So we need the number of votes here and votes. And votes equals new int array of the size of answers. We have as many number of votes as we have answers. Now, the request handler can start a request. It's going to do whatever it wants to update the votes and change the count. So, this is going to be private because we want to make sure that the callback is correctly called. So, add vote, int and index. Let's add a certain number of and vote increase. Vote number index is going to grow and vote increase. And since the vote changed, onVoteCount changed dot invoke. Same thing, we are going to allow to read and of course get vote count to get the entire array. Int being a not being a class, it's going to return a copy of the array and not the exact array. So there is no way to change this array. Now we can see it better. Now we can imagine it better. So the request manager starts a new request. It has a request handler, current request handler. And something, I'm not sure what yet, is going to say this is, for example, new Twitch API handler. This is going to be our request handler. When it starts a new request, current request handler dot start request, we create a new request. We ask the request handler to start it. If it could, we return the request. Otherwise, we return null. So the user asked to start a new request. We create the request. We ask our request handler to start handling the request. If it's managing to do it, it returns the request. If not, it returns null. The most attentive of you are going to notice that we are maybe creating a request for no reason. This is bad for memory. So our request handler is going to need, I was wrong. This is going to need public bool can start request. That way we ask if it can start a request first. Then if it tells us that it can, we create the request and we tell it to start the request. And we return the request that is being handled. Does that make sense? And as you can see, with the interface, this is not such a hard code to stomach. So let's summarize. We have the request manager that allows us to start a new request. A request being a question and answers. If the current request handler can start a request, so the request handler being the Twitch API, the Discord API, anything, this will allow us to create a debugger later. Okay, so we create the request, we start it, we return it, and if we can't, it's null. Anything, any other piece of code, therefore, only has to do request manager dot start new request, question, answers, and check if whatever is returned is null. And now it can do anything it wants with the request, including counting the change and requesting it to be finished. There's one thing we haven't done, and that is the ability to stop a request. Public static void stop request to stop. Whew, that's a mouthful. And again, current request handler dot stop request to stop. Function is missing. Generate it. It's public. It can be called by anything. Stops an request. On Twitch, it's going to stop the poll. On Discord, it's going to close or lock a thread. There are different behaviors to stop the request, so that's why we are going with an interface. There we are. We already have the base to our open source request system. Okay, this is going faster and better than I expected. It's actually much easier than I thought it was going to be. This is the end of chapter 2 of the video. But you know what? We are going to make a debugger in chapter 3. So in chapter 3, we are going to simulate a chat that answers questions. See ya then!